Hey folks, problem number 2. A regression line is constructed to predict the student's GPA based upon the number of hours studied per week. The data was based on 50 students who studied from 0 to 20 hours per week, and that gave us a least squared regression line of y equals 0.14x plus 1.12. So basically, you tell me how many hours you study per week, and I will predict your GPA. Okay, seems reasonable. First question A, in the context of the problem, what does this 0.14 represent? Oh, it's next to the x, so you'd say the slope. And I'd say, yeah, it's the slope, mathematically speaking, but in the context of the problem, what does it mean? So remember, the slope is sort of a rise over a run. So what's rising, what's running in this in the context of this problem? So what's increasing, so that's a GPA increase, and this is an extra hours studied. So the slope, yes, it's a slope, but what does it actually mean in the context of the problem? So for every extra hour of study per week, your GPA should increase by 0.14. Okay, that makes sense. So if that makes sense, what does the 1.12 mean within the context of the problem? It's the y-intercept. Yeah. Algebraically, I get what you're saying. It's the y-intercept. But in the context of the problem, what does it mean? The 1.12 in the context of the problem would be, if x was 0, your GPA would be 1.12. Oh, okay. So yeah, that's a y-intercept. So basically, if you don't study, if you study 0 hours, if you study 0 hours per week, 0 hours per week, your expected GPA is 1.12. Aha! So this is a cool little example because the slope actually has some meaning in the context of the problem, and the y-intercept has some meaning in the context of the problem. That's not necessarily the case. So in the homework, you'll be doing problems and they'll say, oh, does the slope have any meaning? And sometimes you'll just be like, oh, no, not really. Does the y-intercept have any meaning? Oh, maybe not. So just be careful. Sometimes it does. Sometimes this does. Sometimes this does. Sometimes they both do. So this is a cool case where they both have meaning. So if we actually go back in time to the mother-daughter height one, so we could say, where was that? Oh, that was right here. So we had, this was our least squares regression line. So the slope, what does the slope mean? So for every 1 inch of the mother's height, the daughter should be 0.8. See, but then you have that. Yeah, it doesn't really make sense. So in this context, I would say that the slope doesn't have much meaning, and the y-intercept doesn't have much meaning. This one's a little bit too complicated, so no real good meaning in that one. Okay, so you'll see the homework is like that also. Okay, where were we? Part C. Part C says, what would you predict the GPA to be of a student that has studied 15 hours per week? Okay, 15. Oh, so I just throw 15 into my least squares regression line. So y hat is equal to 0.14 plus 1.12. So I put 15 right here. So grab my calculator. Okay, 0.14 times 15, enter, plus 1.12, enter. Expected GPA of 3.22. Okay, so I was comfortable throwing the 15 into my least squares regression line because it says this least squares regression line was created, was based upon 50 students who studied from 0 to 20 hours per week, 0 to 20. So you see how the 15 is in that interval of 0 to 20. Okay, I'm comfortable using 15. So in part D, they say something weird. They say, oh, what if someone studies 60 hours per week? Oh, well, my linear model was built, it was designed, it was based on people studying 0 to 20. So I don't really want to put 60 in there. Well, could you? I guess I could. Okay, so it's just numbers. I could throw 60 in there. But it doesn't make sense, right? Because the whole model is based on 0 to 20. But if I just throw it in there, I'll probably get some weird GPA. 0.14 times 60, enter, plus 1.12, enter. Oh, nice GPA of 9.52, which is weird. So basically, when you're plugging in a value that's outside of your data, it goes beyond, extra, beyond. So that's extrapolation. So be careful with extrapolation. Sometimes you don't get results that make sense. I'm comfortable plugging in 15 because it's within the 0 to 20 data. So as long as I'm inside, that's interpolation. Interpolation. Okay, so these are words that are often used, interpolation. So for example, if you want me to figure out the price of oil in 2010, so that's sort of going back in time. I have a bunch of data over the years. I would be interpolating. I could probably get a good estimate of the price of oil. If you want me to figure out the price of oil in the year 2030, you see how I'm going into the future? I don't have any data out there. I'm going beyond my data, so it's extrapolation. So predicting the future is always extrapolation. So extrapolation isn't bad. You just want to stay kind of close to your data. So like, can you predict the price of the oil tomorrow? Yeah, probably. 2 days out? Sure. A week? Yeah. A month? 10 years? See how the further you get away from your data, the more complicated. So the further away from the data you extrapolate, the less confident you should be with those numbers. So be comfy with the terms, the vocab interpolation, and extrapolation. Was that all of our questions on that one? Yes. Okay. Cool.